Hello. So our topic is Amplitude Shift Keying. Uh, Team members are Ashish Margudri, Shoshot Kulkarni, and Inakoti Maurya. So what is ASK? Amplitude Shift Keying is a form of amplitude modulation that represents digital data as variations in the amplitude of a carrier wave. Okay, so in an ASK system, the binary symbol 1 represented by transmitting a fixed amplitude carrier wave and fixed frequency for a bit duration of t seconds. If signal value is 1, then the carrier signal will be transmitted, otherwise a signal value of 0 will be transmitted. So what is our aim? To construct and study amplitude shift keying modulation and demodulation circuit and to analyze the waveforms. So let's proceed with the modulation. So in modulation we are going to cover 5 things. First is block diagram, second is components required, third is CAD circuit diagram, fourth is experimented circuit, and fifth is CAD output and experimented output. This is the block diagram of the modulation. First, the carrier sinusoidal and message signal is sent to the product modulator, and then it is passed to band pass filter, and then after we get an ASK modulated wave as output. So, what are the components required? It is IC741. It is an op-amp comparator, operational amplifier, transistor BC107, resistors, DC power supply, oscilloscope, and a function generator, and the breadboards and other things. So this is the pin configuration for IC741. It is an op-amp of comparator. So these are the pin configuration. On 2, it's an inverting input. I'll soon show you in the circuit. 4 and 7 are plus V and minus V are plus 15 volt and minus 15 volt. Okay, so this is the CAD circuit diagram. So in this circuit diagram, the 15 the 15 plus 15, this is 7, so this is IC741. This is the inverting and this is the positive. This is the carrier signal we are giving of 5 to 10 kilohertz and 1 bpp. This is the message signal of 1 kilohertz and 1 bpp. uh, this is a BC107 transistor. We are giving a 5 volt VCC to the 1K resistor, and from 6 pin of the comparator we get the output. Okay, so this is what we implemented experimented circuit. So this black over here is the IC741. It's not visible, and other are these black wires are from oscilloscopes and the wave generator. So this is what a CAD output we get. This is the modulating signal which we are giving an input. This is also carrier signal which we are giving an input, and this is the output signal ASK modulation after the modulation. Okay, so output experimented. So after the circuit which is shown in this here, we had run by giving carrier signal as 5 to 10 kilohertz and 1 bpp, and message signal as 1 kilohertz and 1 bpp. We get this output, and this is similar to this output. We get a bit noise, but this is what we get in reality. So let's go to demodulation. In demodulation, we are going to cover 5 things: block diagram, components required, CAD circuit diagram, experimented circuit, CAD output, and experimented output. The same as we did in the modulation. So this is the block diagram for demodulation. First, okay. So in the output from the ASK output, which is we get over the 6th pin. This is given to the square law detector, and then it is passed to the low pass filter, then it is passed to the comparator and to the voltage limiter, and then we get a demodulated signal which we expect. So these are the components required. IC741 as for the modulator, modulation and all, and for the demodulation we need one more, that is diode 0 0A79 and capacitors 1 microfarad. and the same as digital oscilloscope and a waveform generator, and with some breadboard and connecting wires. So this is the complete circuit diagram of the amplitude shift keying. The first half is the ASK modulation, and the second half is for demodulation. So um, so this is the modulation, like I have told before. This is the comparator IC741, and this is the BC107 transistor, and then this is the diode 0A79. So we give this is the sixth output is we get from modulation, and then these are put in parallel, 100 ohms and 1 microfarad, and then we get the output, demodulated output. So let's go to the output. So this is actually the complete circuit which we had done on the breadboard with the wiring, and also this red and black wires which you can see are uh, from function generator and the oscilloscope. Now, this is the modulating signal which we uh, applied in the modulation circuit. This is the carrier signal. Carrier signal carries the modulating signal, and this is what we get after the modulation generated ASK signal. This we got in the modulation, and this is the demodulated signal of CAD. So these are the square pulses with one gap, and so this is what we exactly got after implementing this circuit, experiment circuit. After implementing this circuit, we got the output, experimental output. So this is what we are now. The output becomes the sixth pin is the output for the demodulation circuit. So this this is the output of the demodulation circuit, and this is the sorry, this is the input of the demodulation circuit, and this is the output of the demodulation circuit. So this is exactly what we get in ASK modulation demodulation. Thank you.